This is the last example I want to put together for you for some extra problems in chapter 4 and 5. And take a look at this thing. I mean, how this problem is ridiculous. You've got fractions, you've got fractional exponents, which are really scary, and they're even negative fractional exponents. So the first thing I want to do is I'm going to rewrite this thing with all positive exponents. Okay, this thing starts to look a lot better when we write it with no negative exponents. The one thing I want to point out here that where students are going to make a mistake is this. 8/3 times x is really 8x over 3. So that's where the 8/3 x went. Now I want to talk about how can we add these two expressions that don't have a common denominator. Well, I'm going to have to find something to multiply by the denominator, by the rational expression on the left. I need to multiply this by something so that the denominator matches this. And I'm going to show you a little trick for that over on the right. So somehow I need to make x minus 2 to the 4/3 look like 3 times x minus 2 to the 7/3. The first thing, which is probably pretty easy for you to see, is I need a 3. The second thing, which may not be so easy, is I need to turn 4/3 into 7/3. So as I was saying, the next thing I need to do is make x minus 2 to the 4/3 into x minus 2 to the 7/3. Well, I'm going to need an x minus 2 in here. But what exponent do I need on it? Well, if I have something to the 4/3 power, I need to add another exponent so that it equals 7/3. And hopefully you're savvy enough to figure out that that exponent should be 3/3, which is the same as 1. So to get a common denominator between these two expressions, I have to multiply by 3 times x minus 2 in both the numerator and the denominator. I'm going to go ahead and do that now. When I multiply negative 4 times 3, I get negative 12. I'm now ready to distribute that. That gives me negative 12x plus 24 plus 8x over my denominator of 3 times quantity x minus 2 to the 7/3. There's some like terms I can combine in my numerator to get negative 4x plus 24 divided by 3 times x minus 2 to the 7/3. Still less than or equal to 0. I can factor out a negative 4 in my numerator. That's going to be negative 4 times the quantity x minus 6 over 3 times the quantity x minus 2 to the 7/3. Less than or equal to 0. We're now ready to construct a sign chart for this bad boy because we've got it completely factored. And the points we need to mark on our number line are 6, because 6 makes our numerator equal to 0, and 2, because 2 makes our denominator equal to 0. Just like in the previous example I did, we have a negative constant in our numerator. So our sign chart is going to start with a negative value. I also want to comment on this exponent. The exponent is 7/3, which is really the cube root of x minus 2 to the 7th power. Because those values are both odd numbers, they preserve the sign of the input. So if I input if x minus 2 is negative, when I raise it to the 7/3 power, it'll still be negative. Why does that matter? Well, that matters because I can ignore that exponent and just look at the sign of x minus 2. So I have 3 factors I'm going to consider in each of these intervals. The negative 4 is always negative. Let's start out at the right of positive 6. Out to the right of positive 6, all of these factors are positive. So I have a positive, and 2 positives and negative, that results in a negative. As I cross over in between 2 and 6, the factor of x minus 6 will turn negative, and it will actually stay negative along the rest of the number line. In this interval, though, the x minus 2 is still positive. Well, I have two negatives and one positive. The result is positive. As I cross over to from this interval to the left of 2, as I was saying, as I cross over this interval from between 2 and 6 to the left of 6, the factor of x minus 2 in the denominator turns negative. So I have three negative factors. That results in an overall negative. Some of you might be wondering about this. You might say, hey, Mr. Vass, how come you totally ignored this 3? Well, that 3 is positive, and it doesn't affect the sign chart. And we're almost done with this problem. And what looked really difficult at the start really isn't so bad after all, because now I just have to look at my sign chart and determine the intervals where this thing is less than or equal to 0. I'm going to start at negative infinity, go up to 2. I'm going to put an open parenthesis there because the rational expression isn't defined at x equals 2. And then I'm going to have a square bracket at 6 because less than or equal to 0 means we can be 0. To positive infinity, and there's our final answer.